Let's call the number that we're trying to find x. Then the square of it is 12 more than the number itself. So I can write down x squared is x plus 12. And the cube of the number, so that's x cubed, is 9 times the number. What is the number? Well, let me first of all deal with this equation. Although there's a cube in there, there's only two terms, so it makes it easier than the first equation. And what we can do is see that either x is 0, or if it's not 0, we can actually divide through by x to give x squared equals 9. If x squared is 9, we can take the square root, and this gives plus or minus 3. You must remember the minus part of the square root as well. So we've got three possible solutions. Let's test each of them. If we put 0 back in to the top one, remember this equation must also be satisfied, then it doesn't work. We get 0 equals 12, so I can reject this one. If I put 3 in, I get 9 equals 15. So plus 3 doesn't work either. Minus 3. Now if I square minus 3, I get 9. And then on the right-hand side, I also get 9. So the answer must be minus 3. I'm going to talk about a few other ways to do this question. First of all, instead of dividing through by x, I could have done x cubed minus 9x equals 0 and factorized this expression, x times x squared minus 9. Now, you may not have covered solving quadratics and even cubics yet, but I'm going to talk a little bit about it. Two things are being multiplied to give 0. It must be that either this is 0 or this is 0. Okay, there's no way that you can multiply, like 5 by 7 to get 0. You just don't. It only happens if one of the things, or both of them, but not going to be both here, is equal to 0. So this gives x equals 0. And this bit here, it must be, well, like we might be able to see 3 or minus 3, but I could go and say that, okay, x squared minus 9 must equal 0, and then x squared equals 9, and then we get the plus or minus 3. So it's a really powerful method for solving equations. And then we like carry on from here, just like I did before. The alternative thing is we can actually factorize the quadratic. This is often taught later on in school again, so this is why I'm really adding it as an extra. But if you've learned how to expand double brackets, then you might have noticed that when you expand a double bracket, you get x squared, then you get plus 3x and plus 2x. You end up basically adding the numbers here to give the term with the x in, and then it's plus 6. You end up timesing the numbers to give this. So we can use that idea to factorize quadratics, try and find two numbers that multiply to give minus 12 and add to give minus 1. In fact, minus 4 and plus 3 would work. And then we get x, just like I argued it before, either this is 0, so x minus 4 is 0, meaning x is 4, or x plus 3 is 0, meaning x is minus 3. And then we could put that into this equation and see that it only works when we have minus 3. So a few different ways to tackle this problem. Well done.